In this video, we're going to use the sum and difference formulas to find exact values of trigonometric functions. And specifically, we're going to look at part D, the tangent of alpha minus beta. So first off, we have a formula that we're given, the tangent difference identity formula. I've got that pasted here. Just took a screenshot of that. And for this formula, we're going to need to have the tangent of alpha and the tangent of beta. We can see from the given information that we already have been given the tangent of beta, that's displayed over here. So really what we need to find is the tangent of alpha. We know that there's a relationship between sine and cosine that could give us a tangent of an angle. And interestingly, we have another given piece of information, the sine of alpha, okay, the same angle that we're trying to find the tangent of. So let's see what we can do with this value and a Pythagorean identity. So I've just brought in here that Pythagorean identity theorem. Again, we know the we know the sine of alpha. So we can make a substitution here. So that is 3/5. That value will be squared. And what we can get with this substitution is the cosine of alpha. So let's do these steps to find the cosine of alpha. So first square 3/5, that gives us 9/25. Next subtract 9/25 from both sides. This will isolate cosine squared of alpha, and we get that that equals 16/25. And then the last thing is we'll take the square root of both sides, and we do have to consider both the positive and negative for a moment. But when we come back to the given information, we see that alpha is in a particular quadrant. It's between the angle -3π/2 and -pi. So if we think about that and where it falls on a coordinate plane, that would be the third quadrant. So we will only keep the negative sign here because cosine of an angle in the third quadrant would be negative. Now that we have the cosine of alpha and we were already given the sine of alpha, we can use this trig identity that the tangent of alpha equals the sine of alpha over the cosine of alpha, substitute, and we can get the tangent of alpha. So we first substitute, and then calculating that, or simplifying that, we get that the tangent of alpha is -3/4. So at this stage, we have the tangent of alpha. Again, we were already given the tangent of beta, so we have everything that we need for our difference formula for tangent. So here I've just made those substitutions, and we now have this expression that we would probably need to further simplify because it's not commonly accepted to leave fractions within fractions or radicals in a denominator. So let's start just by cleaning this up just a little bit. And multiplying down here in the denominator. And I do see 3 denominators within this entire fraction, and one thing I could do is multiply essentially by the number 1, but it shares all the common denominators that we have, which would be 4 square root of 3 over 4 square root of 3. That's essentially multiplying by 1, which is the same thing, so I would not be changing the value here. So I'm going to be distributing, starting with the 4 square root of 3 in the numerator. 4s would become 1. 4 divided by 4 anyway would become 1. So I would be left with -3 square root of 3. And this next fraction, when I multiply it by 4 square root of 3, those square root of 3's would be eliminated. And then here in the denominator, same thing. Okay, and that's one step closer. So at least now I don't have fractions within fractions or our complex fraction. So the next step would be to rationalize this denominator. And I could do that by multiplying by 4 square root of 3 minus 3, both numerator and denominator. So here I've just worked that process out, distributing twice, or you can even think of it as some other, I guess, techniques like FOIL. Maybe you've heard of that one. But the nice thing that happens is those radical terms in the denominator will be eliminated. And let's just clean this up a little bit more, simplifying a little bit more. So combining a few more like terms, this is what we end up with. This is our final answer to what is the tangent of alpha minus beta.